you go. Thank you to football. All right, so here we go. We are on 3.5. This is page 36, and we are going to spend this entire section solving equations. And we're going to do it in a couple of different ways. The first section, number 1, says no calculator. So we are solving these equations without our calculator. All right? So I bet most of you, probably all of you, can look at that problem and tell me what x is. 3. And x is 3 because 8 is 2 cubed. So one way to solve an exponential equation, that is an equation where the variable is the exponent, is to make both sides have the same base, because then the exponents have to be equal. Doesn't that make perfectly good sense?
Yeah.
Yeah. So let's look at the next one. What do you think you might want to do with this one? Before we start in, what do you think we might want to do? Divide by 3. So 4 to the x equals 16. We always want to divide by that extra number. So that extra number out there in front, we want to divide by it. Okay? So we got rid of that number. And now we have 4 to the x equals 16, and everybody knows then that x equals 2, because 16 is 4 squared. You don't have to write that down, but I want you to understand that's what's happening. You have the same base on both sides of your equation, so therefore your exponents are equal. Now, look at the next one. Remember, we're going to solve this without a calculator. We have got to get the same base on both sides. Like here we had 4 to the x equals 4 squared. We had 2 to the x equals 2 cubed. What are we going to do with 4 and 8? Katie?
Well, what I was thinking is like wouldn't it be a fraction and you would do like the square root and then do the cube?
Exactly. So Katie just figured it out. She said, listen, there's no way to turn a 4 into an 8 directly with a whole number. So I'm going to have a fractional exponent. So she thought through it and she's answered the question. For those of us that maybe can't think through it quite that well, or maybe it's going to be a tougher problem sometime and none of us can figure it out, think that 4 and 8 are both powers of 2. Would you agree with that? That 4 is 2 squared. Oh, Meg.
Yeah.
Did you just come in late?
Yeah, I had about.
You okay?
Yeah, I can hardly talk.
Okay, then no. You agree. Okay, so 2 squared is 4, and 2 cubed is 8. So now they're both 2's, so I can set the exponents equal to each other. So 2x equals 3, and x equals 3 halves, which is exactly what Katie said it was going to be. Now, if you can figure it out, kids, then figure it out. You don't have to go through these steps if you don't want to. But if you can't figure it out, then these are the steps you'll go through to get the answer. It's what we call getting a common base, making the bases match. All right, letter D. What about that one? What do you think about D? what are we gonna do first?
Divide both sides by 3.
Yep, we do not want, and in a minute, we're gonna be doing some logarithmic equations. We never want this extra number out in front, ever. We never want him. When we do word problems after Thanksgiving, we're gonna have this extra number all the time. The first thing you're gonna do is get rid of it. So we're gonna have 4 to the 2x equals 32. Okay, I know 32 is kind of a special number. What is it? 2 to the 5th? 2 times 2 times 2 5 times? So, oh wait, this side's 2 to the 5th. What's this side? 2 squared to the 2x. 4 is 2 squared. Now, they're both 2's. So our exponents are equal. So 4x equals 5 and x equals 5/4. That one would be harder to figure out just by figuring. So getting a common base is probably a good idea here. So we changed them both into 2's. If you don't have a calculator available, if I'm not letting you use a calculator, then you are always gonna be able to do this. You gotta figure out what it is, but you're always gonna be able to get a common base, unless it's a calculator problem. All right, E. What's the first thing we're gonna do, Peter? Divide. Yep. So 5 to the x over 3 equals 125. Anything special about 125? What?
Cube
Not cube, it's 5 cubed. Yep, it's 5 to the 3rd. So 5 to the x over 3 equals 5 cubed. Remember, I just got done telling you, you're always gonna be able to get a common base if you don't have a calculator. So since this is a 5 and there's not much you can do with a 5, start playing around with 125. How many 5s is it? Now it's 5 times 5 times 5. So x over 3 equals 3 and x equals 9 is our answer. Are you feeling pretty confident? Let's try F and G on your own and with your partner and compare. See if you can come up with answers to F and G. And if you think you can do either one, I'd love to have you come up and put it on the board.
I'll do one that's for.
Great.
Oh, you just like go up there?
Yeah. And if anybody's kind of afraid to do it on your own, you can take a friend.
You don't have anything to cheat.
Did you swim on Saturday?
All three.
How'd you do?
Yeah, I'll take it.
You did okay?
I didn't make it.
You did?
Yeah, I'll take
Awesome. In 100 free?
it. Yes.
What did you get?
How'd the relay do?
We did okay, we could have done better, but To be fair, I was really pro like this.
Like, I feel like it's
You win some, you lose some. Oh my gosh.
like one hand,
Yeah, it's very strong.
Okay, well, Jake's over there. Off the radio. I'm gonna try to read
Oh,
this. Yeah, that's okay.
like, I'm already.
So I'm reproducing,
Did you?
I think, what Jake said. Alright, so hopefully everybody divided by 2 first, and then you have a 9 and a 27. It really doesn't get much easier than that. 9 and 27 are both powers of 3, so 3 squared and 3 cubed. Now, the bases are the same, so you can set your exponents equal. Because this exponent is like a quantity, that's going to be a distributive. So 2x plus 6 equals 3. Yep, that's exactly what he did. Beautiful. So 2x equals -3. Did he get -3 halves? Perfect. Beautiful. Beautiful, beautiful.
Can I do D?
Yep. There you go. Eli's doing this one. Do it over here, honey. That way I don't have to redo it. There you go. All right, he's going to do this one. Did you recognize, like Eli did, that 1/4 is 1/2 squared? So we could use 1/2 as our common base in this problem. And he got 8. Is that what everybody got? Not lots of nods all around, take your coat off. Guys, you gotta be in uniform, get your lanyards on, take your coats off, you know the drill. Don't make me cranky. Okay, I want to do one more of these because H has a little bit of trickiness in it. So I want to do this one together. We have a short period, so we don't need to do every single problem, but I do want to do this one. This is H. What is the first step? Divide by 27. So 1/3 to the x equals, 9. Now 9 is 3 squared. I'm pretty programmed to that. What do I do with the 1/3? It's 1/. What do I do with that, Drew?
So if you make it negative, it flips.
Exactly. So 1/3 is 3 to the -1st. Would you agree with that? You need to make the bases match. So the minute I made this 3 squared, which was my choice, you don't have to do that, but for me that's kind of automatic to think of that as 3 squared. Then I had to make this one a 3. So they'd be the same? Well, it's a 1/3. 1/, means negative exponents. So I rewrote 1/3 as 3 to the -1st. Well, now they match. So negative x equals 2 and x equals -2. Is that all right with everybody? Okay. So that was problem H. Well, J, I'm just skipping I, it's the same thing. We practiced enough of those. J is this. That's different. Totally different looking problem. Still no calculator. You know how to do it though. It's the loop-de-loop, exactly. Sydney says it's the loop-de-loop. So when you loop-de-loop, you start with your base always. So we're gonna start with the 7. 7 to the x equals 49. Well, shoot, you know what x is. 7 to the x is 49, so x has to be 2. Remember, we're doing this without a calculator, so it has to work out nicely. It has to. Okay. Again, pretty basic here. What's that one gonna say? 2 to the 3rd equals x, so x equals 8. I can try to complicate it by making more stuff in the problem, but it's still super simple. Still super simple. Emma, what am I gonna do with this one?
Are you gonna put the 2 as the exponent?
I am, so I'm gonna loop-de-loop it. So it's gonna be 4, always start with the base. So 4 to the 2nd equals that whole thing, x plus 2. So 16 equals x plus 2 and x equals 14. Everybody still with me here? It looks more complicated, but it's not bad. All right, do M. Do M on your own. Tell me what happens with M. I'm looking over Sydney's shoulder because she has the misfortune of sitting right in front of me. X equals -8. Is that good? All right, look it in. What's step 1? Think about what we did earlier. What are you gonna do first with N? Divide, divide, divide. You do not want this number out here. In any of these equations, we do not want that number out there. When you divide, kids, the only thing that changes is that 2 disappears. So don't change anything in the logarithm. That 2 cancels that 2. That's all that happens. And then you can loop-de-loop. And I got 15. How about you? Last one of these has a little bit of craziness going on. Look at it carefully. Drew, what are you doing? Put it away. Yes, thank you. We're gonna move that 6. Does this look out of place to you? Compare with all the work that we've done on these preceding equations. That 6 does not seem like I want it there. So I'm gonna move it to the other side. And then divide by -3, and all that does is take that away. It doesn't change anything over here on this side of the equation. Turns that into a 2. And then 6 squared equals 4 plus x. Did you get 32? Perfect, perfect, perfect. Great. All of those problems, a whole bunch of them, no calculator. We did not need a calculator at all. Why is it that in problem 2A, I think I need a calculator? This looks like the ones we just got done doing. Why do I need a calculator in this one? No, we had those at the beginning, Jake. The one you came to the board and did had an X in the exponent. Nyla?
Because 18, is not a power of 2.
Well, actually, what do I want to do first in this problem?
Divide this.
I gotta divide the 6. But, Nyla, then I get 3. Can I get a common base with 2 and 3? No. So in all the problems I did without a calculator, I had things like 2s and 4s and 8s. I could get a common base, 3s and 27s. Can't do it with 2 and 3. So, if you cannot get a common base, the only way to solve this problem is to take the logarithm of both sides. Okay? Now, Mrs. Ford, why in the world are you taking the logarithm of both sides? Well, think about your properties. What can I do with an exponent if I'm taking the logarithm of that expression? Where can I put that exponent? Out in front? Remember that? The exponent can come out in front. So I can rewrite this x plus 1 log 2 equals log 3. So now the x plus 1 isn't up here anymore. Now it's down on the level with the equation. The log of 2 is a number. Like if you type log 2 on your calculator, it comes up point whatever, it's a number. So I'm going to divide those sides by the log of 2. So x plus 1 equals whatever this is. So I'm going to type that in on my calculator carefully, because when I type log, that parentheses comes in. Make sure you close it before you divide. So log 3, close parentheses, divided by log 2. I got 1.5850. We had some problems before where we rounded to the 10,000, so I'm just rounding to the 10,000. Don't mess up your rounding. This one's kind of a tricky one. 1, 2, 3, 4 decimal places would be here. 6 means round up, but if I try to round up a 49, it's gonna have to go to a 50. Now, subtract 1, and 0.5850 is the answer to the question. If you cannot get a common base, then you're going to use logarithms. When solving an exponential equation, and that's an equation with an x and an exponent spot, if you're solving one, you either get a common base or you use logarithms. That's it. Those are your two options. All right, here we go. Don't panic. Same kind of problem. What do we do first? Divide by 17. Now, let's not round off. That doesn't go in evenly. That's going to be some kind of crazy decimal. Don't worry about it. Just leave it be for a second. I really don't want to round off till the end. I get my x's. Katie, is your hand trying to go up there?
Did we use a natural log?
Yes. Now, let's be clear on something. Natural logarithms, common logarithms, base e, base 10, they're all logarithms. So anything you can do with one of them, you can do with the other. If you are an LOG person and you want a LOG, you can always LOG. But if the problem already has an E in it, then it is going to be more convenient, easy to use natural logarithms. You can live a perfectly happy, normal life without ever doing anything but LOG. So if that's what you want to do, go do it. But here's the beauty of this. When an ln and an e touch each other, and I mean touch each other, there's no number in between, there's no square root in between, it is literally ln and e. They will always cancel. They are inverses of each other, they will cancel. So x equals ln 93 over 17. Anytime the problem has an e, when you ln it, it's gonna be gone, and you're gonna have just x equal to. So the answer to that one, ln 93 divided by 17, 1.6994. All right, 500, or excuse me, 50, e to the negative 0.112x equals 200. We're gonna run into equations like this all the time in our word problems, so we need to be able to handle it. Charlie, what do you think maybe we should do to get started?
Divide by 50?
Yep, and this time I can actually do it. 200 divided by 50 is 4. So I'll go ahead and do the division because I don't need to round it off. Now it's got an E. So while I could LOG, I think I'll LN. That's gonna take that out of the equation. So negative 0.112x equals ln4. Are you still with me? This is so cool. So x equals ln4 divided by negative 0.112. You just type it in. Don't forget to close the parentheses after the 4. I got negative 12.3776. All right, try D. D on your own. And maybe E, you can get a couple volunteers up here, maybe somebody to do D and somebody to do E. Remember, we have a calculator, so we're not afraid of these decimals. Yoo-hoo, where are my volunteers?
Oh, I got it.
You are such a good volunteer, I appreciate that. Jacob, do I have any other good volunteers?
Be right over there.
Yeah, I'll move over here. Erase all this.
Are you doing
first thing Jake did was divide by 3 in problem D, is that what you did? And I think Van hopefully divided by 81, yep. In problem E, we've got to get rid of that coefficient out there. I also got 2.1447 for that one. Does anybody have a question about D? Anybody not get D? Now, notice Jake chose to use LOG. He could have used LN. There wouldn't have been any benefit to it, do you understand that? But it wouldn't have hurt anything. He could have used LN. In fact, if you type LN 3.24 divided by LN 1.73, this is what you're going to get. Van, on the other hand, is using LN because he's got E's. He wants to get rid of that. Oh, be careful. Is this a positive number? Okay, when you subtract 1, you won't get that. Right, you see what I'm saying? So use a calculator to subtract 1. You get 29, 6 more. Negative. There you go, then divide that by 4. Yep, that's what I got. Perfect, perfect, perfect. Thank you. Thank you, thank you, thank you. Anybody have a question about Van's problem? You got it? You guys are amazing human beings. All right, tell me about F. It's got a little bit more stuff in it, but it's exactly the same scenario. Amanda, what are we gonna do first in problem F?
Subtract 10,
Bingo. And then what are we gonna do, Amanda?
divide by 5.
Yep. And that actually divides by 5, doesn't it?
Yeah, 38.
38. And then we can log both sides. You need to write down as many steps as you need to write down. I'm writing down like all the steps. You may not need to write down all the steps. Don't skip too many though. We don't want you to get messed up. 3.3111. Alright. Make sure everybody, make sure you're okay with that. Are you okay with that? So, if I have an x up in the exponent of any kind of equation, I have 2 choices. I either get a common base or I use logarithms, right? And if it's on a test or quiz and it's no calculator, then you know you're going to have to get a common base, right? And you'll be able to figure it out if you don't have a calculator. All right, now we've got a few more logarithm equations. We're almost out of time. Let's try a couple of these. These are the same thing we were looking at before, except bigger. More stuff is in it. So Jaden, I'm on number 3A. It's a logarithmic equation. What do you think I should do first? First thing I'm gonna do is subtract 3, that's exactly right. So -2 log base 6x plus 2 equals 2, perfect. Katie?
Divide by -2.
Divide by -2, so log base 6x plus 2 equals -1. Then we need to get rid of the logarithm to solve. So we're gonna loop-de-loop. That's what we do when our equation looks like this. Call it whatever you want, but it's that loop-de-loop motion. So 6 to the negative first equals x plus 2. What's 6 to the negative first? 1 over 6. So x plus 2 equals 1 over 6. So x equals 1 over 6 minus 2. Now, if we don't have a calculator for this problem, we're going to have to be able to subtract fractions. How do we subtract fractions? Common denominator. So this is 1/6 minus 12/6. So negative 11/6. One more and we'll be done for the day. Ready? Done for like forever, for a long time. 3 ln x minus 2 equals 4. Don't panic. Ln's just another logarithm. So, step 1, add 2. So 3 ln x equals 6. Be careful. What do I need to do now? I gotta get rid of that 3. So ln x equals 2. And then, yeah, what's ln stand for? Log base. Ln is log base e. Log, common logarithm, base 10. Ln, natural logarithm, base e. So there's like an e there. So when I loop-de-loop it, I get e to the second equals x. Now, no calculator, we're done. E squared is it. If you have a calculator, do you know how to type e squared in on your calculator? Second ln pulls up e, and then just hit 2, and it's 7.3891 would be the decimal. So if it's a no calculator, we're gonna leave it as e squared. All right? Okay, you guys, have a